All right, we're going to talk about electrochemistry. Electrochemistry is using redox reactions, that's reactions involving transfer of electrons, to create electricity. And we do this by having voltaic cells, such as the one on the screen. We have copper 2 plus, we have platinum 2 plus, and we have platinum. This line right here, this double line, this is the salt bridge. This is what separates the anode from the cathode. And at the anode, we have oxidation occurring. At the cathode, we have reduction occurring. Okay, so for the oxidation, we have copper going to copper 2 plus. This is oxidation because copper has a 0 oxidation number here, plus 2 here. So to go from 0 to plus 2, you have to lose electrons. Remember, electrons are negative. So it's losing 2 electrons. This is happening at the anode. At the cathode, we have reduction occurring. Now, reduction happens not when things lose electrons, but when they gain electrons. That means electrons are a reactant. And to go from platinum 2 plus to just platinum, you have to gain 2 electrons. So this is my oxidation reaction, this is my reduction reaction. I put these two together, copper solid plus platinum 2 plus 2 electrons. I'm going to put that there. Goes to form copper 2 plus platinum. This is solid. Plus 2 electrons. Notice the electrons cancel out. They will if this is a proper reaction. If they don't, we need to multiply that amount to make sure they balance. All right, so this is my reaction. Let's actually go something off, not what it's asked. So what this means is I'd have one container here that has an electrode in it. This electrode would be made out of copper. It would have a solution that has copper 2 plus. This would be connected to another electrode, that's platinum, in a solution that has platinum 2 plus. Okay? I have to combine these two by a salt bridge. The salt bridge is just needed in order to balance charge. Okay? Now, at the anode, what's going to happen is copper is going to go and form copper 2 plus. So over time, this is going to shrink away. Right? My copper is slowly going to copper 2 plus. And so this creates a bunch of electrons. So this is a negative anode. And then these electrons can go through here to the platinum. Now I have some electrons, and these electrons are going to combine with the platinum 2 plus to form platinum. And so over time, this is actually going to grow. Right? This is going to shrink. This is going to grow as we form that platinum solid. Okay? This is a voltaic cell. Okay, so let's answer the rest of the questions because I got off on a tangent. What's being oxidized? Well, oxidized is copper. What's being reduced? The reduced is platinum 2 plus. Okay. What is the anode made of? It's made of copper. And what's the cathode made of? It's made of platinum. Now you may be thinking, oh, I have two things. What's the electrode? An electrode is a piece of metal, right? I can't have a metal that's aqueous, right? It's got to be this solid platinum. All right, so this is our answer to 26A. Right? We start off by looking at the anode, which is on the left-hand side, and then the cathode. At the anode, we have oxidation occurring. at the cathode we have reduction. All right, let's go ahead and let's move on to, now that we've talked about voltaic cells, now let's go ahead and figure out something about cell potential. Cell potential tells me the voltage that can come from a voltaic cell. So in this case, we have magnesium going to magnesium 2+, and we have nickel 2+ going to nickel. All right, so which one of these is oxidation, which one's reduction? Let's see. This, it's losing electrons, so this is oxidation, this is reduction. So if we were to write this in cell notation, it's not really an AS, but let's do it. We'd say magnesium, magnesium 2+, because the anode comes first. Then nickel 2+, nickel. All right, but to figure out the cell potential, E naught, we need to go ahead and we need to go the reduction potential at the cathode minus that at the anode. All right, so which one is the cathode? The cathode is going to be whichever one has the higher reduction potential. In that case, that is the nickel. So that's going to be negative 0.257 minus negative 2.372. This is going to end up giving me positive 2.115 volts. Okay, oops, it's capital. All right, that is my cell potential. Okay, here it is on the screen. I start off by figuring out what's oxidized and what's reduced. The one that gets reduced is the one that has the bigger reduction potential. Okay, all right, let's move on to 26C. 26C says we have a voltaic cell that has a nickel electrode in nickel 2+, and tin, that's SN, in tin 2+ solution. And we're asked what's reduced and what's oxidized, what's the overall chemical reaction, and what is the cell potential. All right, so we have a lot of information here on the left. These are all reduction reactions because they all involve gaining electrons. That's reduction. Okay, which ones do I care about? Well, only one of these involves nickel, so I'm going to care about this. And notice there are two tin ones. There's one which has tin 2+ and tin solid, and then tin 4+ and tin 2+. Well, I care about these two, right? Because that's what I'm told is in my voltaic cell. Okay, so now let's go ahead and do this on the board. So we're told, or we're asked which one gets reduced. The one that gets reduced is the one with the highest reduction potential. That's going to be the tin, right? So tin is reduced. Okay? So that means it's going to be just as written. SN2+ plus 2 electrons going to form tin. Okay? What gets oxidized then? The one that doesn't get reduced gets oxidized. So nickel is oxidized. And so seeing that on the screen right there, that's my reduction reaction. The oxidation reaction is going to be the flip. So that's going to be nickel going to nickel 2+ plus 2 electrons. Okay, so tin is reduced, nickel is oxidized. Let's go ahead and put these two together. So I'm going to get tin 2+ plus nickel goes to form tin plus nickel 2+. Let's go ahead and remember our states. If it has a charge, it's always aqueous or a plasma. We're not dealing with plasmas in this class, so aqueous. Aqueous, or no, this is solid and aqueous. All right. Okay, now what is the cell potential? The cell potential is always the one that gets reduced, the cathode, which is the one getting reduced, minus the anode. All right, so what I'm going to do is I'm going to go ahead and I'm going to say, okay, that will be negative 0.1375 minus negative 0.257. Okay, so that's going to be negative 0.1375 plus 0.257. So that's going to get me 0.1195 volts. Cell potentials are for voltaic cells are always positive. All right, here it is on the screen. I figure out which one is reduced based on the fact that it has the higher reduction potential. The other one must be oxidized, which happens at the anode. Once I have those two half reactions, one that's oxidation, one that's reduction, I add them together to get the total reaction, and then I figure out the cell potential based on the difference between these two reduction potentials. All right, this is the last video I'm making before the review. So sad. Talk to you later.